Applications of differentiation are related rates of change example. The volume, V centimeters per cubed, of water in a container is given by the expression V equals 12H squared, where H in centimeters is the depth of the water. Water is flowing into the container at a steady rate of 90 centimeters cubed per second, and we're being asked to find the rate in centimeters per second at which the depth of the water is increasing when H is 3. Let's look at what we're given here. We know the steady rate is 90 centimeters cubed per second. Centimeters cubed is a volume expression and second is time. So in other words, dV dt, the rate of change of volume with respect to time, is 90 centimeters cubed per second. So the dimensions is a good clue to understanding what we're given here. What is it we've been asked to find? Well, it's the rate of change of H with respect to time in centimeters per second. So we're being asked for dH dt. Again, there's a clue in the dimensions because it's centimeters per second, a distance divided by time. So we want to know what dH dt is. That's our question. It's a related rates of change question because we can't find this directly. However, we can express dH dt in terms of the thing that we're given, in terms of dV dt. So the H dt is equal to dV dt multiplied by, now what we would like is a dH on top and a dV underneath, so that the dVs are undoing each other. So here we have a parametric formula for finding dH dt. dH dt, the thing that we want to find, is equal to dV dt, the thing that we were given, multiplied by dH dV. So we're going to perform a differentiation here. Do we have a formula that represents V in terms of H? Well, we were given this at the start. We were told that V equals 12H squared. Differentiating with respect to H, multiplying by the power, reducing the power by 1, 12H squared becomes 24H. Now this is not exactly what we want. We want the inverse of this. We want dH dV. So that will be 1 over 24H. So now we have the elements to be able to solve our question. We know that dH dt is dV dt, which is 90, multiplied by dH dV, which is 1 over 24H. This reduces to 15 over 4H centimeters per second. We've been asked to evaluate this when H is equal to 3 centimeters. So we sub in 3 for H, giving 15 over 4 times 3, or 15 over 12. And that reduces down to 5 over 4 centimeters per second.